Hello. Have you ever found yourself in a motion profile trying to move liquid and you're getting a lot of sloshing or a lot of movement in your product and it looks a little bit something like this? Today I'm going to show you how to take that out, and we're going to go from a very sloshy, very jerky movement to a very smooth movement where we take all the slosh out. Today I'm going to introduce the concept of vibration compensation within the CMMT-AS Servo. Now today in this project we've got a CMMT-AS C2 servo with an EMMT-AS 60 Servo Drive. We're connected with an ELGD actuator, and then of course we've got our mounting kit. In this particular instance, you have already seen that I've got a glass jar sitting on top of one of our actuators, and I am basically moving it from one point to another point within the motion profile. And the way that we're set up today to do this is I went into the record table and I've set up two different records. So we have our record table. The record table is moving from one position to another position and just repeating the loop over and over again. We're going to run this on a manual control just to demonstrate this purposes. But this same thing could apply if you're running this in a PLC control. The first thing that we want to do is we want to go into diagnostics, and we're going to go to trace configuration. We're going to actually set up a trace. And the only two things that I care about monitoring right now is I want to look at the actual current and I want to look at the actual velocity of what is being commanded. We're going to run this trace for 10 seconds, and the trace preferences, I'm going to start the trace manually, and then we'll go from there. So in order to do that, we're going to go back to control, and we're going to start the record table. As soon as I start the record table, I am then going to start the trace. So we're going to start the trace, start the record. We're going to collect this data. We can see that we get this real jerky movement. Okay, now our trace is complete. We're going to go ahead and stop this movement. We're going to go back to diagnostics, and let's look at the trace. Let's see why it is acting the way it is. With any servo, any motion command, currently what we're telling this thing to do is basically go from a dead stop to set speed for a length of time distance, and then once it gets there, it's supposed to ramp back down. Once it gets to 0, we change direction, we go back. So here we're at 0. We're going to accelerate to our actual velocity of 0.4, and we can see what our current is doing. Our current is in blue, and our commanded velocity is in black. And we can see here that the current goes up, gets to speed, it then comes back down, which it should be doing because it's not needing any more load. This is just the acceleration. And then we slowly start to slow back down to 0, and we turn back and we go the other direction. But the one thing that we notice with this movement is very square. It's a very square wave, right? It's start, go as fast as we can until we get to said position, then we need to stop as fast as we can, right? So we get this very square wave. So let's see what we can do to maybe round this out a little bit to take out some of the sloshing and things that we got going on with this type of control. So we're going to go to parameterization. We're going to go to axes, and we're going to go to vibration compensation. Under vibration compensation, you can see that we have notch filters 1, 2, and 3, and vibration frequencies 1 and 2. One thing to keep in mind is these notch filters plus vibration always have to be activated by this little checkbox. If that box is not activated, your filters or your vibration frequencies are not inactive. So we're going to focus on vibration frequencies today, and we're really only going to look at vibration frequency number 1. So the way the CMMT drive works is we've got a natural frequency in hertz. And if we go over here to the little square box, we can see that this frequency is a minimum of 2 and go all the way to 100 hertz. Basically what we're doing with this vibration frequency is we are interrupting at a certain frequency in the control to smooth out that signal to get away from that harshness of what we're seeing. Now, if we had vibrations number 1 at 2 and vibration number 2 at 4, it would enact, and these were both enabled, it would enact at 2 hertz and 4 hertz and work in conjunction. Let's take a look at this. So what we're going to do is we're going to go to here, we're going to activate this. Now we're going to go back. We can see up here at the top it says store on device. Now I don't need to store on device right now because I am in testing mode, but I can. until we get done finding out what this natural frequency is, I'm not going to really do a store on device. So we've got 2 hertz in here. We're going to go back to control. And what we're doing is we're collecting data, right? So we're going to go ahead, we're going to start, and we're going to start the trace. And here we can see that we still got some sloshing going on, but the jar is not jumping all over the actuator. So we're going to go ahead and stop this movement. We're going to go back into diagnostic. And now we're going to look at trace number 1. As you can see, as we trace, our traces are displayed over here and we keep them in conjunction. So this was our first trace, right? No vibration compensation. We've got a really square wave going on up and down. Look at trace number 2. If we look at this trace now, we're starting to get more into a curvature of our movement, which is good. We're not so square. But some of the things we can take a look at here and kind of get an idea of what's going on, right? We've got these areas in here, like at this 0.3 of the velocity, that it's hanging out for quite a while, right? As we accelerate. We've also seeing that down here at 0.2, and we're also seeing it on the other end at 0.3 or 0.6. So let's take a look at this. So we can see in the video, right, we were still doing a little bit. We're kind of hanging out. So basically we're telling the velocity to go here, hang out for a minute, then I want you to accelerate faster. I don't want you to really hang out here for a minute. So now I've got a time for this to get in some more vibration, right? It's better, but it's still not good enough. So let's go back into parameterization. We're going to go to vibration compensation. And now you notice this is 2 decimal places. I'm going to go ahead and I'm going to go to 3. I'm going to go to 3 on the frequency. And we're going to go over here to control. We're going to start this and we're going to trace it. Now, if we look at this, we can see our jar is not moving around. Our liquid is very stable. And as soon as this trace finishes, we'll go ahead and stop. And we're going to go to diagnostic and we're going to continue. So let's look at trace record number 2. Trace record number 2 from trace record number 1 looks a lot different, right? We're not getting these peaks and these valleys up here like we were. We're starting to slowly come up and then slowly come back down. Now we still got a few little steps in here, right? But they're not as long of a duration of a step as what we had in here. We've got really long duration steps in here. We don't really want that, right? Let's see. We've gone from no compensation. We put 2 hertz in. Now we're up to 3 hertz. So what I want to do is I want to go in here and I want to rename this record. So I'm going to say this is going to be, I'm going to rename this trace record. So we're going to say 3 hertz. I'm going to rename that. We're going to rename this one so we keep track of things to 2 hertz. So I'm just right clicking on it. We're going to say this is going to be 2 hertz. And we're going to say no compensation. We're going to say rename no comp. Let's keep on moving up. Let's see what happens. So we're going to go back to parameterization, back to vibration compensation. We're going to go to 4 hertz. And we're going to go back to control and we're going to rinse and repeat. Let's start a trace. We can see here, we're starting to get a little bit more sloshing going on with the jar. A little bit more pronounced of a sloshing. Now the jar's not jumping around, but our liquid is sloshing. So let's stop this. Let's go to diagnostic. Let's look at our trace. So we're going to rename this 4 hertz. And if we look at this 4 hertz graph, we can see that we're a lot sharper acceleration and deceleration rate. Whereas in 3 hertz, it's a little bit more pronounced. The time constant is a little bit more. So let's look at our steps, right? Our steps are a lot longer in time duration in 2 hertz. We'll get to 3 hertz. We still have our same steps, but our time duration at that step is not as much, and we're continuing to accelerate. At 4 hertz, right in this area in here, we can see that we're stepping just a little bit, but not as pronounced as we are here at 3, right? So we're taking out this acceleration a little bit more at 3 versus 4. If we look at this, and then even down here, in this area here, we are seeing that it's a little bit longer in 3 hertz versus 4 hertz. So it's trying to get to speed faster at 4 hertz, which tells us that 4 hertz is not our sweet spot. So if we're going to go back to 3 hertz, we're going to set this thing to 3, and we're going to go back to our control. Go ahead and run this. We'll start another trace, collect this data, and we can see we're rarely getting any sloshing, right? The movement of the liquid is maintained with what is going on because we're taking that vibration out. We're taking the amount of jerkiness out of that. We'll go ahead and stop this, go back to diagnostics. And again, our trace number 3 is where it's at. It looks really, really good. So I hope this helps with vibration, what vibration compensation does for you and how you can actually look at it. So the thing to keep in mind with vibration suppression and what we're doing here with this is that we're basically doing input shaping into the set point value of the servo. It has no effect on the closed loop control or the stability of the closed loop control. So just want to keep that in mind that we're actually not affecting any of our closed loop parameters in that sense. So I hope this helps.